Hey everyone, welcome to CamLearn online classes. So basically today we are going to start with the acids and bases chapter. Before starting with the chapter, let me tell you about my online chemistry classes. So if you want to score more in your chemistry, you can definitely join our classes. These classes will be taken live on the Google Meets, and you will have every support will be provided, right? You can get the Google form in the description, and from description, if you are interested, you can definitely fill the form. So let's start with the chapter. Hello everyone, welcome to our today's session. So today we are going to start with the class 10 IGCSE. Okay, the first chapter that we will be doing is acids and bases. The other 10 chapters which you have already studied in 9th standard, you will also see their lectures in coming days, okay, in coming time. But right now we will be starting with the acids and bases chapter. Okay, so let's start with the acids and bases. So basically acids and bases, we are aware of a bit of it, right? So if we talk about acids, what are acids, students? Acids are nothing but the substances which are present in our daily life substances also. So what are the different daily life substances we have? As you can see the picture over here, we have grapefruit, oranges and lemon picture given over here. So why it is given? It's because these things, or these citrus fruits, contains the acid. It means this acid is not harmful for us. Yes, that's correct. So the acid which is present in these all substances or citrus fruits, so these are actually called as organic acids, and they are completely good for our health. They are not harmful for our health. Okay, and that's the reason we can actually drink them or eat them. Okay, so not only the citrus fruits but also vinegar, lemon juice, grapefruit juices, and also the spoiled milk. Okay, everyone will now comment in the comment basically over here, that you have to tell me that which acid is present in the spoiled milk. Okay everyone, I'm going to reply each and every one of you, so make sure you are also answering this. So spoiled milk contains basically the which acid, that you have to answer, okay, in the comment section. So these all things are actually sour in taste. So when you talk about the acid taste of the acid, so it is basically sour. Okay, it has a sour taste. But this we can taste, or this we can say, it's because we are talking about organic acids. Not all the acids can be tasted. Okay, do not at all try this in your school. Okay, in your of course in the school, because in the school we have many, in the laboratories we have acids, right? So do not taste those acids. So acids basically which are present in animal and the plant material, they are actually called as organic acids, and they are not much harmful for us. Also, one example that we have is a carbonic acid. So carbonic acid basically present in most of the fizzy drinks. So how carbonic acid is been formed? Carbonic acid has been formed from carbon dioxide which is dissolved in water. So when you dissolve carbon dioxide in water, it forms H2CO3. That's nothing but our carbonic acid, which is again good for our health, because not, of course, it should be in limit. Okay, if you are increasing its limit a lot, then it is very bad for our health. But it is edible actually. And why it is edible, why we can actually have it? It's because it is weak and dilute. Okay, the acid that we have here is carbonic acid, and this acid is weak and dilute in nature, and that's why dilute in nature, rather dilute in this particular fizzy drinks, and that's why we can drink it. So these are the acids which are organic acids. Okay, now of course carbonic acid is not the organic acid, but I will tell you the another type of acid that we have is mineral acids. Okay, mineral acids. So what are the mineral acids we have? So generally in laboratory we have studied about HCl, we have studied about H2SO4, such acids, right? So these acids are actually called as mineral acids, and of course these acids cannot be tasted. You cannot taste it. Okay, and that's why they comes under this category, that's mineral acids. Okay, where they can be used? So they are actually corrosive in nature. Uses we will see right now, but before that you can see they are also corrosive in nature. Okay, and they can eat their way through clothing, and they are dangerous on the skin as well, and some are even able to attack the stonework and the metals. So they are so reactive also. Okay, so we need to be very very careful while working with these acids. Okay, so overall we have understood right now that acid, when it comes to acid, so acids are present in our daily life things. So that is, for example, the citrus fruits, spoiled milk. You are going to comment the name which is of the name of the acid which is present in spoiled milk. And also vinegar. In vinegar also, in vinegar we have which acid? We have a acetic or ethanoic acid. Okay, ethanoic acid. So that is also been we basically use it in our cooking purposes, right? So these are the things. Also, other than that, what are different things you should know about acids? So when acid dissolves in water, you need to know that it actually forms H plus ions. Okay, most of the students are always, when I ask them the definition of acids, they always say that acids are the substances which has hydrogen in it. Okay, but not only hydrogen. This is the wrong statement. Hydrogen ions, we have to say, that is H plus ions. Okay, so acids contains H plus ions actually, and when you dissolve them in water, they forms this H plus ions. For example, if I dissolve HCl, so if I dissolve HCl in water, so it will form H plus ions and Cl minus ions in the solution, right? So it dissolve in water. After that, they show this H plus ions are present. And if they have H plus ions after dissolution, so definitely, don't you think they will able to also donate it, right? If anyone comes and they ask for the H plus ions, so definitely they can donate, because it has protons, so it has H plus ions. So that's why acids acts as proton donors or H plus donors. Protons meaning only H plus. Okay, hydrogen ion donors. So we have to be very very careful about it, and we should know about it. Okay, that acids can act as a acid acts as basically proton donors. So as they're acting as a proton donor, they have H plus ions, so they are acidic in nature, and we know litmus paper turns red when we put it in the acid solution, and the pH of these such solutions or these solutions is basically 7, less than 7. Okay, then corrosive nature. So what does it mean by corrosive nature? So corrosive substance meaning is the one that can dissolve or eat away at other materials, for example wood, metal or human skin. So generally acids that we have, they are corrosive in nature, right? And even we carry HCl in our body also, right, in our stomach, right? But that is not that harmful because it is dilute in nature, and it actually helps in digestion. Then, so you can see some of the common acids given with their uses. So organic acids, which are having like which you can see ethanoic acid, methanoic acid, lactic acid, citric acid. So you don't have to remember their formulas as such, but you should know that their nature is weak. They are weak acids. Okay, they are considered as weak acids. So vinegar, in vinegar ethanoic acid is present. In ant and nettle stings, in kettle descaler they are used. Then sour milk, okay, in the sour milk. So yes, I hope you must have commented already. So answer also you got. So lactic acid is present in the sour milk. Okay, and then in lemons, oranges, we have seen the citric acid is present. Okay, so citrus fruits basically contains a citric acid. Then let's talk about mineral acid. So when it comes to mineral acid, so we have HCl, HNO3, H2SO4, H3PO4. All of them are actually strong. Okay, all of them are strong acids. And if you see, of course, then since they cannot be used as a food purpose or as a like for the eating purposes, and that's the reason you can see they are mostly used for the cleaning and all, right? So HCl is used in cleaning metal surfaces. Also HCl is found in our stomach as a dilute form. Nitric acid used in making fertilizers and explosives, and sulfuric acid present in car batteries and also used in fertilizers, paints and detergents, and phosphoric acid is present in anti-rust paint used in making fertilizers again. Okay, so whenever you will see the nitrogen, sulfur, phosphorus, right? So mostly you will see everywhere fertilizers will be definitely there. The fertilizers, in fertilizers making, they used a lot. Okay, so this is one thing. Also there is one acid which is left, that's carbonic acid, which is actually a mineral acid, but it is still edible. It is used in fizzy soft drinks, which we have seen over here already. It is called as carbonic acid. H2CO3 is the formula, and it is weak acid. Okay, we can dilute, we have seen, right? So it's a weak acid. All right, now after this let's talk about indicators. Now before starting with the indicators, I will give you a quick idea of the bases. Okay, so acids we have already covered, and in that we have seen that acids have H plus ions, right? Similarly, when it comes to alkalis, okay, alkalis, now alkalis are also called as bases. okay, but we should know the basic difference between the alkalis and bases. Okay, so let's understand, because we have the same terms, right? We use it quite similarly, right? So alkalis meaning the bases which are soluble in nature, okay, which are soluble basically. So, and when it comes to bases, so bases are actually insoluble in nature. They are insoluble in water. Okay, so alkalis, like for example, we have NaOH, we have um, KOH, potassium hydroxide, right? Even you can also consider calcium hydroxide, right? So these are hydroxides, okay? These hydroxides are nothing but alkalis. So they are soluble in nature. Okay, they are soluble in water. So when you dissolve them in water, they will form Na plus ions and HOH minus ions, and that's why they are soluble bases. They are called as soluble bases. But you can call them as base also, and that's why always remember that all the alkalis can be called as bases. They are bases only, but not all bases are alkalis. Okay, all the alkalis are bases, but not all bases are alkalis. So what are the examples we have for bases? So we have the examples of bases, that is calcium oxide, MgO, magnesium oxide, right? So these are the examples we have. So basically these are oxides of metal, right? Oxides of metal which are basic in nature, but they will not be dissolved, they will not be soluble, right? And that's why they have the different category of naming, that is insoluble base. Okay, now also one more thing, as we have studied about hydrogen ions are present in acids, in a same way when we define alkalis or define bases, because bases are also alkalis, right? Bases not bases are not alkalis, sorry, but alkalis can be called as bases, right? So that's why when we define base, we say that bases are the one, or the alkalis are the one which has hydroxides ion. Okay, hydroxide ions, hydroxides or hydroxide ion. So which ion? OH minus, because as I told you, that is, suppose if NaOH is you are dissolving in water, it will form Na plus ion and OH minus ions. Okay, so this is about alkalis and bases, a bit short introduction of it. Also pH will be more than 7. We will be learning about it in detail also, but let's quickly now move ahead to the indicators. Now when it comes to indicators, you all know indicators are used mainly for the indication, okay, whether the substance that you have, whether the solution that you have is acidic or not, or if it is acidic or it is basic, right? So basically we find out that by using the different indicators. So what are the different indicators we have? We have litmus, we have thymophthalate, we have methyl orange, and I'm going to give you one more indicator, that is nothing but phenolphthalein, and phenolphthalein is one of the important indicator. Okay, so what are the color changes are there? So basically from exam point of view, you don't have to remember everything like what are litmus and all, how it has been prepared. So actually litmus is prepared from the lichens are bryophorites actually. So they are purple in the color, like if you talk about the litmus solution, so it is purple in color. Okay, so we need to know the color change, that is more than enough. Okay, so when it comes to litmus solution, so as its neutral color is purple, okay, purple is the neutral color of the litmus solution. So when you add the litmus solution to the acidic solution or acid basically, so that purple color changes to red, and the red color indicates that the solution that you are actually testing is actually acid. Okay, but if it's not red color and if it is turning the color from purple to blue, it means the solution is alkaline, and if it is not changing the color, it means the neutral solution you are testing. Okay, so what is the color change in the litmus paper? From purple to red for acid, from purple to blue for alkali. Very important from exam point of view. Then thymophthalate is the another indicator that we have. So thymophthalate, it doesn't have its own color, it is colorless when it is neutral in nature. When it is neutral, basically its own color is color, there is no any color actually. So so thymophthalate in acid again doesn't show any color. Okay, doesn't show any color. Now remember, if it is not showing any color when you're doing this, performing this particular thing in the laboratory, you will understand that colorless solutions, if thymophthalate is showing the colorless solution or colorless change, so it is, you will not able to figure out whether the substance is neutral or acid. and then for that you have to go for the another test. Okay, that is very very important. So for phenolphthalein, this case is there that for acid it is not useful actually. You, for the testing of acids, you cannot use phenolphthalein. Even the same thing for phenolphthalein. Okay, just write down the correct spelling of phenolphthalein. Okay, I'm just writing it once again. So it is PHENOL PHTHLEIN. Okay, so even the phenolphthalein that we have, it is again neutral in nature. Okay, neutral, meaning it doesn't have any color. It's same as thymophthalate. So phenolphthalein is also colorless in nature when it is neutral. And in acid also it is colorless. Okay, in acid also it is colorless. There is again for the phenolphthalein there is no use for acid. Like for the testing of acid, you cannot use thymophthalate and phenolphthalein because you cannot get any color. Okay, so that's a change that you see of the color, or there is no any change only that is happening. But if the color is changing to blue when you are using the thymophthalate indicator, so it means the solution that you are testing is alkali. Whereas for phenolphthalein, the color change for alkali is pink. Okay, should I write it down in the pink so that you will remember it? So yeah, is it pink? It is not, but chalo, no problem. So it is pink. Okay, so the color change that you have in phenolphthalein, for alkali it's colorless to pink. Okay, then for the methyl orange, the color change that you have now, from exam point of view, phenolphthalein is very 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 important. You can just do the 5 stars to it because very very important. So its own color is orange, as its name suggests, methyl orange, but the color in acid is red, and the color change in the alkali is yellow. Okay, so when orange to red color change you will see, it means the solution is acid, and the orange to yellow color change, when you see, that's nothing but your alkali. Okay, now the next thing that you have is universal indicator. Now from these indicators which we have studied right now over here, from here you will only understand the nature of the solution, whether it is a acidic one or the alkali, okay, or the basic one. But universal indicators are far more than that. So what are first of all universal indicators? Universal indicators are the mixture of indicator dyes. Many dyes are actually mixed in it, and that's why this is the reason you will get the different or the various or the range of colors, actually range of various colors for the pH values or for the nature of the acids, right? So basically what happens to your acid that you have, so you can even find out its pH range by using the universal indicator, because the range of various colors you will get when you test your substances with the universal indicator. So if the red color you are getting, the dark red color you are getting as your change in the color, so after adding the universal indicator into the acidic solution, so you can see over here the color change that you have is red, and the range, if the red color is there, it means the strongly acidic substance you are testing, and the color range or the pH range that you have is 0 to around 2.5. Okay, after that yellow, for the orange, sorry, so for orange basically it's weakly acidic. Okay, you can consider it as weakly acidic, and the color range or the pH range will be 3 to 5. If yellow color you are getting, as you can see the color range over here, you have a yellow color range. So yellow color shows it is again weakly acidic, and 5 to 6 is the range for our 5 to 6.5 is the color range for the yellow. Okay, pH range for the yellow. And if the green color solution you are getting, it means it is neutral. Okay, the pH will be 7. Then the blue color indicates the weakly alkaline solution, and the pH range will be like pH range will be from 8 to 10.5 or 10. Then violet color, even the various shades of violet you will see over here. Okay, it will be bit darker, it will be again a less lighter and all. Okay, but the violet color, if you are getting, whether it is lighter or a darker, but it will be a strongly alkaline solution, and the pH range will start from 11 to 14. Okay, so 11 to 14 you can consider as a strong pH range or the strong alkaline pH range. Okay, and over here lesser. Okay, so from here you can conclude that lower the pH value, higher the acidity, and higher the pH value, more the alkalinity. Okay, this is something that you should be very much aware of, because question comes in very twisted way, so you have to be very careful about it. Then the next we have is pH scale. Okay, so pH scale is basically given over here, as you can see. So most useful measures of the relative strength of an acid or alkaline solution is pH scale, and pH scale is starts from 1 to 14, and if the pH is less than 7, it means the acids we have. And of course, as I told you, more acidic a solution, lower the pH, right? And for neutral substances, pure, like for example pure water, the pH will be 7. And the alkalis which have more pH than 7, it means they are alkalis. Okay, the solutions that we have is alkali. Okay, also right now luckily we also have the digital pH meters. Yes, as you can see, so you just have to put the pH electrode into the solution, and directly you will get to know what is the exact pH value of that solution, which is very interesting right now. Okay, it's a very good advancement that has been done in the science, right? So this is also very interesting. Of course, there will not be any much questions will be used, but in ATP papers you can even mention about the pH meters while explaining the experiment which has been there. Okay, which is related to pH actually. Okay, now over here you have the range of the different common solutions given, again their pH values. So hydrochloric acid is actually around 1. Then gastric juices will have again 1 only. Lemon juices 2.5, vinegar 3, acid rain 4.4, rainwater 5.6, urine 6, milk 6.5. Pure water sugar solution has the 7 neutral value or the 7 pH. And after that, blood has 7.4 pH, baking soda solution has 8.5 pH, toothpaste has 9 pH, life water 11, household ammonia that we use 12, and sodium hydroxide which is used in our soaps basically. So they are actually, you're having strongest, they are stronger pH actually, it has a stronger alkalinity, so that's our NaOH 40. And if you are interested in the online chemistry classes for IGCSE focused, so you can definitely fill the form which is given in the description. All right, so bye bye.